This presentation is going to show Kapow's ability to extract documents and metadata directly from Documentum's web user interface. The problem with the traditional approaches to migrating content from Documentum is that Documentum uses a complex database schema that is unique to each site. This makes it very difficult to reverse engineer these structures and get the content, metadata, and files. The solution with Kapow is going to the web front end. From there, we can extract an inventory of all the folders, subfolders, all the files, and the metadata of those files. So this is an overview of our approach. We're extracting the content from Documentum's UI, and from there, all of the files and metadata can be transformed and organized to match the target CMS data structure. The files and metadata are then loaded to the target system. This process is divided into 5 tasks, each completed by a separate Kapow robot. The first robot will take the input folders to be crawled from an Excel spreadsheet file. The next robot creates an inventory of all the subfolders that belong to those folders to be crawled. The next robot will create an inventory of all the file names and metadata and store them to the intermediate database. Next, the files are saved to the local hard drive. From here, the files and metadata are loaded into the target CMS. This is the Kapow Design Studio. The main window is an extraction and integration browser. Content in the browser can be selected, and then steps can be created that define how we interact with the selected content. Each step that's created is added to the robot that you see up above to perform extractions, transformations, and loading of content into various data structures. This is the Excel spreadsheet file that's used as the input for the first robot. The input spreadsheet can contain any number of folders to be crawled. The robot will iterate through each row of the spreadsheet and create an entry in the task database table. The next set of robots will run in parallel and assign themselves to each of the tasks in this database. This robot is deployed in parallel to spider the UI's front end and find all of the subfolders for each of the selected folders to be crawled. The robot logs into Documentum's management interface and begins to loop through each of the target folders, collecting all of the subfolders and the subfolders of those subfolders and saving the folder hierarchy into the intermediate database. This database table of all folder locations is then used as input for the third robot, which also runs in parallel. The third robot will create an inventory of all file items along with all the properties and metadata associated with each of those files. After all of the properties that are available on the initial screen have been extracted, we click into the properties page for each of the files. From here, we collect all of the other properties that are available for each of the files. All of the files, properties, and metadata are stored in the intermediate database, structured for consumption by the target CMS. And then the robot continues with a loop step, looping through all of the files and all of the subdirectories until all of the file names, properties, and metadata have been collected. The file extraction robot also runs multiple instances in parallel to allow the files to be extracted as fast as possible up to the limitations of the server. The robot will loop through the database of file names collected by the prior robot. The logic here will generate the path based on the locale. Here we're looking up the subdomain associated with each locale. Here the robot's checking the file type to determine how each file should be downloaded. Non-HTML files are accessed by their source URL, which has been constructed by the prior steps. HTML is retrieved from the cache server, where it is stored in its original form before includes or other dynamic elements are added. If the robot is performing an incremental migration or synchronization, the robot will check the generated object key for the file against the existing object keys to determine if new content's been added or if a file is changed. At this point in the robot, additional steps can be added to collect metadata from any other source, any other database systems, file share, or any other sources. Now, the constructed URL source, the path where files have been saved to, and any additional metadata that's been collected is now updated in the intermediate database. A final robot will iterate through the intermediate database, loading all the files and metadata to the target CMS system by way of the target CMS's UI or by using an API loading the content into XML or Sling forms. Contact Content Migration Sales at Kapow Software to see how we can automate your content migration.